Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. And guys, sorry for a small inconvenience. The session has been delayed by around 10-12 minutes due to some technical glitch here. But yes, nevertheless, we are live now, guys. So quickly update your friends, quickly share the session. Although it's late, but it's live. Okay guys, so let's continue our discussions on the Z transforms. Yes, the session is now live. Let us continue our discussions on the Z transform, and today is a very important class. That is the 11. The number is just, a quantity to tell you, but it's all about the expected questions of Z transforms to be covered up in the today's session. The Z transforms, different types of questions, expected types of questions that can be covered up. So, okay, so what are my favorite 11 for Z transform? What concepts can be there? That is what we are going to see this in the today's class, isn't it, guys? Good evening, Samyata. Good evening, Ruby, Arun, Hanif. Very good evening, all. Okay, guys, so let's start and let's continue. Let's continue quickly. Already there has been a delay. Let's move forward. This is the brief intro about me. You already know. This is Rakesh. I have secured All India rank 9th in GATE examination. I completed my Masters from Indian Institute of Science, Bengaluru. Right, a quick update for you, as I've told you previously also, that tomorrow, that is the Thursday, I am coming live with one more session, 11 p.m. 9 p.m. we will have the regular signals class. So 11 p.m. right in the night, I'm coming up with a session talking about when and how to make notes for GATE examination and what is the importance of detailed notes, then short notes and micro notes, right? What is important, more important for a GATE aspirant tomorrow at 11 p.m. on the same channel. And guys, on the BYJU'S exam prep app, a free mega workshop. And this time it's to be taken by me only. Okay. So, Sunday, 17th July at 12:30 p.m. Sunday, 17th July at 12:30 p.m. 7 golden rules to secure single-digit rank in GATE. Yes, guys, 7 golden rules to secure single-digit rank in GATE examination. Okay, that is going to be a free mega workshop for all of you. Now, guys, let's get started. The question number 1 for me. Okay, the question number 1 for me, ready, jumping for you. Here it is on your screen. So do not forget to share the session now to your friends. Okay, so good evening, Shri Vatsan. Okay, so consider a signal xn whose Z transform has been given to you. There is a signal xn whose Z transform has been given to you. Xz is equal to 3z upon z minus 3 whole square for modulus of z greater than 3 with the ROC it has been given to you. Right, and determine the inverse Z transform for x of Z inverse. Determine the inverse Z transform for x of Z inverse, Right, regarding that, Samyata, I will update you tomorrow. Z transform for x of Z inverse. Now, x of Z inverse is like x of 1 by Z. X of Z inverse is like x of 1 by Z. And whose Z transform is x of 1 by Z? Whose Z transform is x of 1 by Z? So you have to try and recall the property that, guys, if xn is having the Z transform of xz, right, it is the time reversal property. X minus n is having the Z transform x of 1 by Z, isn't it? X minus n is having the Z transform x of 1 by Z. That is what is time folding or time reversal property. All properties and concepts we have covered in the previous 2 classes. X minus n has the Z transform x1 by Z. To whose? You need to find the inverse Z transform. So what is the inverse Z transform for x1 by Z? X minus n. X minus n. Right. So what is xn now? Sir, what is xn? Ye bhi dekh lete. What is the xn? To dekho. Xz has been given to you. That is 3z upon z minus 3 whole square for modulus of z greater than 3. This is of what form? This is of the form az upon z minus a whole square. Now you should be able to recall the formula. Az upon z minus a whole square. So what should be the xn? Az upon z minus a whole square. It is the Z transform for n a power n un. It is the Z transform for n a power n un, where the value of a is equal to 3. So n into 3 power n un. Right sided because modulus of z greater than 3. That is why it is right sided with unit step. Is that okay? So n 3 power n un. So what should be your answer? So the answer is x of minus n, that is minus n 3 power minus n u of minus n. Okay. minus n, 3, so 3 power minus n is 1 by 3 power n. That can be written as 1 by 3 power n, u of minus n. Very clearly option number A is correct. Right, 3 power minus n, so this is not correct. वहाँ पे तो n नहीं है. All these are not correct. 3 power minus n is 1 by 3. 3 power minus 1 is 1 by 3. Okay, this is the first question for the day. Let's move ahead to the next one, guys. Next question, ready? Once again, jumping on your screen. Here it is. The Z transform of a sequence is given to you. Xz is 0.5 upon 1 minus 2z inverse. 0.5 upon 1 minus 2z inverse, and it is given that this question, I've seen that in my experience, that this question looks very simple, but it confuses students. It has confused many students in the past also. Iska history hai ye, right? It is given that ROC includes the unit circle. It is given that ROC includes the unit circle. So first of all, हम देखते हैं ना, what should be the x of z? X of z is given by 0.5 is divided by 1 minus 2z inverse. 0.5 is divided by the 1 minus 2z inverse, correct? It is given that ROC includes the unit circle. What should be the value of x0? Right, acha, now, what is the pole here? What is the pole here? Right, so when you equate 1 minus 2z inverse to 0, you are going to get the z is equal to 2. Z inverse will be 1 by 2 and z is equal to 2. So, sir, if the z is equal to 2 is the pole, what should we comment on the ROC? There is something told about the ROC. ROC includes unit circle. See, I told you that this question has a history. Many students, misinterpret the question and they give the wrong answer. Achha, students wrong answer kya dete hai, wo bhi main hint kar deta hu. From here they say that xn can be written as 0.5 separate 1 upon 1 minus az inverse. 1 upon 1 minus az inverse a power n un. Without thinking about the ROC, students say that it is a power n un. Right. So what should be the value of x0? What should be the value of x0? Then the students will happily say, sir, x0 is 0.5 into 2 power 0. Unit step starts from 0, the unit step will be 1. So the answer is 0.5. So the answer is 0.5. And they see that's in the option also, and they happily mark the option, and this can give them negative marking. This can give them negative marking. So let me please clearly highlight in front of you that this is wrong. This portion, this piece, if you are doing, is wrong, because there is something given about the ROC. ROC includes the unit circle. Now there is a single pole at 2. So there are the two types of ROC. Either mod z less than 2, either mod z greater than 2. या तो 2 से छोटा होगा या 2 से बड़ा होगा. Either mod z less than 2, either mod z greater than 2. Right. So what should be the ROC? Right, the ROC should be, to include unit circle, it has to be less than 2, because if it goes greater than 2, it cannot include the unit circle. Mod z less than 2. Mod z less than 2 then means that the signal should be left-sided. Right, you should have a left-sided signal xn. So what is the value of xn? Right, what is the value of xn? 0.5 को तो separate रखते हैं. 1 upon 1 minus az inverse is also the z transform. Is also the z transform of minus a power n minus 2 power n u minus n minus 1. Minus a power n u minus n minus 1 also has the same z transform, 1 upon 1 minus az inverse, but with the interior ROC, left-sided ROC. So u minus n minus 1, we all know that u minus n minus 1 starts from minus 1. So what should be the value of x0? Is 0. This is the correct answer. x0 will be equal to 0. That is absolutely the correct answer, guys. Okay, that is what is absolutely the correct answer. x0 is equal to 0. This is the answer to be marked. Correct option, option number B. The correct option is the option number B. Moving here, next question on your screen. Right, a discrete time signal is given to you. It has the z transform xz. If yz is equal to x minus z, is the z transform of another signal yn. Is the z transform of another signal yn, then what should be the value of? Okay, then what should be the correct option? Right, so this question again readily jumping for you. Read. How left-sided, Madhu? Because whenever the ROC, let me go back. Whenever the ROC is mod z less than something interior of a circle, whenever the ROC is interior of a circle, then it has to be a left-sided signal. Okay, let's move ahead and learn about the next question. Yz is equal to x minus z. यहाँ पे आपका scaling, time scaling property आएगा. Okay, here you have to think about the time scaling property. What was the time scaling property? Let us all see. What was the time scaling property? Sir, xn is having the Z transform xz, right? Then z naught raised to the power n xn, z naught raised to the power n xn has the Z transform x of Z by Z naught. Sorry, I am so sorry. It is not the time scaling. It is a Z scaling. It is the Z scaling case. X of Z by Z naught. But especially here, when you put the Z naught equal to -1, you have -1 power n xn, -1 power n xn, and that will have the Z transform. That will have the, so Z naught is -1, Z upon -1 is minus Z. That will have the Z transform X of minus Z. So now what is given to you? Now what is given to you, sir? YZ is equal to X of minus Z, right? So what should be the Yn? What should be the Yn? Okay, X of minus Z ka inverse Z transform, that is -1 power n xn. -1 power n xn. But sir, there is no option with -1 power n xn. Yn is -1 power n xn, but none of the option is matching here. None of the option is matching here. So what to do? Then you have to take the signal xn. What is xn? Delta n minus 3 to delta n minus 5. Delta n minus 3 plus 2 delta n minus 5. Right. So here you have to use one simple property, that whenever you multiply any function fn multiplied by delta n minus k, that should be equal to f of k. In place of n you put a, k, f of n minus k, delta n minus k. Isko use karenge. Use this identity of unit impulse, and then you can say that, sir, yn is equal to, dekho, -1 power, here the value of k is 3, -1 power 3. Right, then -1 power 5, both are negative only, na? -1 power 3 once is coming, -1 power 5 is coming, and both are negative. Both are minus only. So minus will be left, minus delta n minus 3, minus delta n minus 5. Minus outside here, left is just xn. Minus, if you take outside, whatever is left is just equal to the xn. Let me know any confusion with the calculation. So the correct answer here is minus xn. Correct answer here is minus xn. In general, it is -1 power n xn, but xn is defined only for odd values of time, right? Xn is defined only for odd values of time. This particular xn is defined only for odd values of time. Delta n minus 3, delta n minus 5. Two impulses, one at 3, one at 5. Only odd values of time. That is why -1 power n is minus, remaining part is xn. That's it. So these are all good, thoughtful, property-based questions of Z transform. That is why I'm telling you, important and expected questions. Next one, number 4, ready for you, and it's a GATE 2 mark question, guys. Okay, about the summation. So there is one important point, let me write down here. So we all know that xz is given by the formula summation of xn z raised to the power minus n from n is equal to 0 minus infinity to infinity. But let's take a causal sequence here. Let's take xn as causal, and we know causal sequence. What is the meaning of causal sequence? Xn will be equal to 0 for n is less than 0. For n is less than 0, right? For n is less than 0. So in that case, when you put z equal to 1, when you put down z equal to 1, देखो क्या मिलेगा? Z equal to 1, तो 1 power anything is 1. 1 power anything is 1. You get summation of xn. So Z transform can also be used to simplify the series. Z transform can also be used to simplify the series. So summation of 0 to infinity xn can be x of 1. The value of Z transform at z equal to 1. The value of Z transform at z equal to 1. So now what is the question? Question में बोला है, let S be the summation n alpha power n from n equal to 0 to infinity. So let this be some signal xn. Let this be some signal xn, which is n alpha power n un. See, anyways, the limit is 0 to infinity, na? Okay, so we can even write down un, n alpha power n un. So what is the Z transform for n a power n? Already we know n a power n un has the Z transform, az upon z minus a whole square. Here it is alpha z upon z minus alpha whole square, right? So what is the value of the summation? The value of the summation is the value of Z transform by putting z equal to the 1. तो z को 1 रखेंगे तो 1 upon 1 minus alpha whole square. 1 upon the 1 minus alpha whole square. 1 upon 1 minus alpha whole square. What is the value of alpha such that S is equal to 2 alpha? Now they have given you something, S is equal to 2 alpha, right? S, which is alpha upon 1 minus alpha whole square, is equal to 2 alpha. Alpha, alpha cancel karenge, so 1 minus alpha whole square is equal to 1 by 2. Is it correct? Right, so 1 minus alpha is plus minus 1 by root 2, which is plus minus 0.707, 1 by root 2 ka value. So alpha kitna hoga? There will be the two values of alpha, 1.707 and 1 minus 0.707 will be 0.3, a little less than 0.3, approximately 0.3 likh lete. Right, yeah, approximately 0.29, 293 to be precise. Okay. Now given that modulus of alpha less than 1, so what should be the answer? Alpha is 0.293. It's an NAT type question. Alpha is 0.293. Hope you are enjoying this questions. Hope you are getting the answer. And if you are enjoying, do not forget to like the session. Keep liking the session. Keep updating your interest levels in the session. Yes, guys. Chalo. So next question. Good one again. Summation can be solved by using the Z transform at Z equal to 1. Okay, guys. Next question here. Number 5th, now ready for you, jumping. It's also a GATE. 2 or 3 questions for today I have taken from the GATE also. So GATE 115, 1 mark question. GATE 15. Always now remember, GATE 15 bole to IIT Kanpur. Whenever GATE 15 strikes in the mind, that you should remember it as the IIT Kanpur year. That you should specially note as the IIT Kanpur year. Two causal discrete time signals xn and yn are related as summation property, yn equal to summation xm, right? Let us directly use the property here. Kya bola hai? Y of n is equal to summation of xm from m equal to 0 to n, right? So what should be the yz? Summation property of Z transform. Whenever there is a summation of the signal, Z transform is given by xz divided by 1 minus Z inverse. We saw all the properties. Summation xz upon 1 minus Z inverse. Now yz is given to you. If the Z transform of yn is given to you, yz is 2 upon z minus 1 whole square. Then what is the value of x2? So pehle xn nikalna padega. First I have to come to the xn. Okay, yz has been given to me. So yz is x of z upon 1 minus z inverse is equal to 2 by z minus 1 whole square. So if I simplify this, this is also z upon z minus 1 actually multiplied by xz is 2 by z minus 1 whole square. One of the z minus 1 power is getting cancelled. So what is the xz? It is equal to, ye z yahan pe divide ho gaya, 2 upon z square z minus 1. It is a 2 upon z square z minus 1. X of z is 2 upon z square. 2 ko bhi separate rakhte hain. Let me make the z square as z cube and then multiply z in the numerator so that we all know what is z upon z minus 1. It is the z transform of an important signal. So xz is now equal to 2 z upon z minus 1 z raised to the power minus 3. 2 z upon z minus 1 z raised to the power minus 3. Correct. Now this is what is the z transform of unit step signal. Z upon z minus 1 is the z transform of unit step signal. So what should be the xn actually? 2un? No, there is z power minus 3 and z power minus 3 comes, z raised to the power minus k comes for the time shifting property. So how much time shifting? N minus 3, right shifting n minus 3. So answer is 2un minus 3. Now they are asking the value of x2. They are asking the value of x2, right? Now 2un minus 3. 2un minus 3 is equal to u of n minus 3. U of n minus 3 starts at n equal to 3. Right shifted it is. Right shifted it is. So this is equal to 2 multiplied by unit step which is equal to 1. But for n greater than equal to 3 and it will be 0 for n is less than 3. So what should be the value of x2 is 0. They are asking at n equal to 2 na. They are asking at n equal to 2 and the signal is equal to 2 for n greater than equal to 3. Rest it is equal to 0. So what should be the value of x2? It is 0. What should be the value of x2? It is 0. What should be the value of x2? That is equal to 0. That is equal to 0. Chalo, moving ahead to the next question here on your screen. Consider the following statements regarding an absolutely summable signal xn which is known to have a pole at z equal to half. Which is known to have a pole at z is equal to half. A very important conceptual question. Okay. Absolutely summable signal which is known to have a pole at z equal to half. Now, when a signal is absolutely summable, its DTFT exists. Some basic points we have learned in the first class only, basics only. DTFT exists. And DTFT exists, that means ROC should include unit circle. DTFT exists, that means ROC should include the unit circle. ROC should include the unit circle, everybody. Remember. Now it is known to have a pole at z is equal to half. It is known to have a pole at z equal to half. There is a pole at z equal to half. There may or may not be other poles. I don't know. Nothing is given. But there is a pole at z equal to half. That is what finally given. That is confirmed. So it is known to have a pole at the z is equal to half. At the z is equal to half. Check karte hain. Which of the options are correct? Okay, xn could be finite duration. Acha, forget this. Hai, let's actually make it as a MSQ question. Forget this section. Let me make it as option number A, option number B, option number C, option number D, and now this is a MSQ question. Now these types of questions only IIT can convert into MSQ concept. Okay, which of the options A, B, C, D is or are correct? One or more option can be correct. Xn could be of finite duration, Xn could be left-sided. So this is, some things are definitely false. Likh dete hai. Let me take that here. Yes, this is definitely wrong. This portion. This is definitely false because a finite duration signal cannot have any pole. What we learned? Finite duration signal ROC is entire Z plane except 0 or infinity. Matlab, if there is a pole, that is either at 0 or infinity or there is no pole. Right? Finite duration signal. Right? There is either no pole. Right, or there is pole at 0 or infinity. There is no other possibility. Either it does not have a pole, or if there is a pole, it may be 0 or infinity, right? So there is a pole at z equal to half. So definitely option number A is false. Definitely option number A is false. Now it could be left-sided, maybe it could be right-sided, it could be two-sided. Ye mujhe dekhna hai. So there is a pole at z is equal to half. I will show you the possibilities. Come here. There is a pole at z is equal to half. We only know that there is a pole at z equal to half. Let me draw a rough sketch here quickly. So it has a pole at z is equal to half. So there are the two possibilities. Number one, right? There is only one pole. There is only one pole, and that is z equal to half. It does not have any other pole. Let us assume, right? Then the ROC is, we all know, mod z greater than half. Sir, why not interior? Why not interior? Because ROC should include unit circle. ROC should include unit circle. That is why you can't go mod z less than half. Right? There has to be the unit circle inclusion here. There has to be the unit circle to be included. I hope this color makes sense here. Yes. So unit circle has to be included. So that is one ROC, mod z greater than half, right? So what is the final ROC here? Mod z greater than half, and that means there is a right-sided signal. There is a right-sided signal. Right-sided signal, because ROC is exterior of a circle only for right-sided signal. Sir, the next case, right? There is a next case, right? One pole at z equal to half. There is a pole at z equal to half. ऐसा नहीं बोला था कि there is only a single pole, but there is one pole at z equal to half. First case, I assume that there is only one pole, right? Second case, I am assuming, and there may be another pole which is outside unit circle. there may be another pole which is outside the unit circle. Figures I'm drawing, I'm taking rough hand drawing. Okay, so don't worry much about the drawing part here. Okay, so there is a pole at z equal to half. There is another pole which may be outside the unit circle. Suppose this is 3. Let me again draw the unit circle. Okay, let's say this is the unit circle available once again. Okay, so I take, suppose there is another pole at 3 and there is a pole at half, right? So what should be the ROC now? ROC cannot be mod z greater than half. Greater than half means infinity and it will include a pole. ROC cannot include a pole, right? Right, ROC cannot include a pole. So this time the ROC has to be confined by both the poles. Because unit circle to include karna hai na. It has to include the unit circle. It has to include the unit circle. So what is the ROC possibility now? 1 by 2 less than mod z less than 3. 3 is just an example, right? 3 is just an example, right? It may be any pole outside unit circle. Now the ROC 1 by 2 less than mod z less than 3. That means it is a ring. That means it is a ring. And ring ROC is for two-sided signal. Ring ROC is for two-sided, but it cannot be left-sided. Left-sided का मतलब क्या है? Left-sided means you will have to take this ROC. And if you take left-sided means interior ROC, mod z less than half. If you take mod z less than half, then unit circle will not come. And unit circle has to come. Unit circle has to come. कौन बोला unit circle आना चाहिए? Unit circle has to come. Who tells you? The question itself tells you. The unit circle has to come. That is why left-sided is also wrong, right? This is right and this is right. So what are the correct answer to the question is option number C and option number D. Multiple select question where C or D could be correct. It could be right-sided or it could be two-sided. These are the two possibilities. These are the two possibilities. A very thoughtful, conceptual, multiple select question. Okay, a thoughtful, conceptual, multiple select question. A thoughtful and a conceptual multiple select question. All okay, guys? Chalo. Next one. Question number 7 ready for you. Z transform of xn is given to you. Z transform of xn is xz cos of z power minus 3. What should be the value of x12? What should be the value of x12? What should be the value of x12? Right. Okay. Chalo. First of all, chemical wala, use it, ask me in the proper language, then only I entertain anything. Oh, great, Sunil Kumar, congratulations. Congratulations for your admission. Congratulations. Chalo guys, what should be the value of x12? Now, listen, one more important point here, one more important lesson to learn here is that with respect to causal sequences, suppose xn is causal. Once again, I tell you, if xn is causal means xn is equal to 0 for n less than 0. So what will be the Z transform? So Z transform of causal sequence, the general formula is summation of xn z raised to the power minus n from n equal to minus infinity to infinity. But because it is causal, I will use the summation 0 to infinity. I will use the summation 0 to infinity. Now let us open up this summation, guys. Let us open up this summation. Try to understand. Let us open up this summation. So this will become x of 0 plus x of 1, z power minus 1 plus x of 2, z power minus 2 plus x of 3, z power minus 3. Right, and etc. x0 plus x1 z inverse plus x2 z power minus 2 plus x3 z power minus 3 and etc. That is what is the answer it should be. That is the expansion for a causal sequence. Okay, so that means Z transform, if expanded, it contains all negative powers of Z. It contains all the negative powers of Z. Acha. Now, few important things to learn here, right? Few important things to learn here. Please make the important note. regarding to the causal signals. This is only and only for causal signals. Number one important note, right? What is the coefficient of z power minus 2? It is x2. What is the coefficient of z power minus 3? It is x3. In general, there will be a term x of k z power minus k, and then again till infinity. The summation is till infinity. So if I generally take any z power minus k, the coefficient is xk. The coefficient is xk. Number one point to be noted is xk is known as the coefficient of z raised to the power minus k. xk is known as the coefficient of z power minus k. Number one point to be noted. Number two point to be noted is कि when you put z tending to infinity, ध्यान देना, when you put the z tending to infinity here, limit z tending to infinity x of z, limit z tending to infinity x of z. So when you put z tending to infinity, 1 z inverse 1 upon infinity, z power minus 2 again 1 upon infinity. So all this will be 1 upon infinity. All the negative powers of z will become 1 by infinity, and 1 upon infinity is 0. So what is only left? It is equal to x0. What is only left is x0, and x0 which may be finite. A finite also there can be two cases. Finite means it may be 0 or non-zero, but it is finite. Right? So for a causal signal, limit z tending to infinity xz is always finite, and that is given by x0. That is given by x0. Some more important points. I'm not deriving it, but I'm telling you some important tricks to remember, right? If x0 is equal to 0, then limit z tending to infinity xz. Okay, इसको पहले मैं एक चीज लिख देता हूं यहाँ पे. Let x of z be nz upon dz. मतलब let there be some numerator by denominator type of expression. Let there be some numerator by denominator type of expression. Right? So third point. If x of 0 is equal to 0, limit z tending to infinity is 0. And for a ratio of polynomial, right, if limit z tending to infinity converges to 0, then the degree of numerator is always less than the degree of denominator. Some simple mathematical clauses I'm including. Degree of numerator less than the degree of denominator, right? And fourth point within this, if x0 is non-zero, it is a non-zero finite value, it is going to be finite, we know, right? Then limit z tending to infinity nz upon dz is finite if both the degrees are equal. We can solve it by the calculus, but I'm just giving you the result, okay? Degree of numerator in that case will be equal to the degree of denominator. Degree of numerator will be equal to the degree of denominator. Some important points for good questions, they will help you. Some important point for good questions, they will help you, right? So if I go back to the question, first of all, let us complete this question. That is the question number 7 here. If I give you this question, xz is cos of z power minus 3. xz is cos of z power minus 3. So can I expand the cosine by the Taylor series? What is the Taylor series for cos theta? What is the expansion for cos theta? It is given by 1 minus theta square by 2 factorial plus theta power 4 by 4 factorial minus theta power 6 upon 6 factorial. Alternate, only even powers, that too with alternate sign. Only even powers, that too with the alternate sign. So what is cos theta? Let us use that. So that is going to be cos of z raised to the power minus 3. That is what is xz, and that becomes 1 minus z raised to the power minus 3 whole square. So z power minus 6 by factorial 2, z power minus 6 by factorial 2 plus z raised to the power minus 3 ka power 4. So z raised to the power minus 12 divided by 4 factorial. Right, minus plus etc. I want the x12. Question में मेरे को क्या बोला था? I want the value of x12. And what is the x12? What should be the x12? X12 is known as per the property we have learned right now, it is the coefficient of z ki power minus 12. It is the coefficient of z ki power minus 12. The coefficient of z ki power minus 12 is 1 upon factorial 4, that is 1 upon 24. 1 upon factorial 4, that is 1 upon 24. So option number B you can mark here. Option number B you can mark here. Is that okay, everybody? Option number B you can mark here. So guys, cos of z power minus 3, cos of 1 upon z cube. What should be the logic? What should be the approach? Try to think that is there any particular signal whose z transform, any particular common signal? So there will be infinite types of signals in the world, but there are some signals which are standard, which are important, whose z transform, Fourier transforms, everything we remember because they are important. So try to recall our important Z transform formula. Is there any important Z transform? Is there any important signal whose Z transform is cos of Z power minus 3? Probably not. That means I don't know what is the Z transform here. So then I can approach it using the series method. The value of x12 is the coefficient of Z power minus 12, and the series will give you the different Z powers. The series will give you the different Z powers, right? Chalo. And remember these important notes, it can be helpful for you. Moving ahead right now to the question number 8, the input-output relationship of a causal stable LTI system is given to you. Causal stable LTI system is given to you. Now, something important to learn here, right? Some important points to recall here for LTI system, right? Okay, some LTI system, causal and stable. पहले individual बोलते हैं, right? If I give you a causal LTI system, quick points to review here. A causal LTI system. So what is the conclusion you have to remember? ROC is exterior of a circle, right? And whenever the ROC is exterior, where does it lie? Where does it lie? Lies outside the outermost pole. It lies outside the outermost pole. Is that okay, everybody? Right. Yes, again, more on causality only, Shubhankar. If it is a stable LTI system, some important points to review. If it is a stable LTI system, then ROC includes unit circle. Right? Number 1 point, number 2 point, and number 3, the important point combining both. If it is a causal as well as stable LTI system, for a causal and stable LTI system, guys, see, causality says that ROC should be exterior of the outermost pole, and stability says that it should also include the unit circle. That means the largest pole, the outermost pole, should be before unit circle. Then only unit circle will be included. You are going outside the outermost pole. Okay, I'm just orally explaining you. Derivation is not required here properly, but just let's keep here. Okay. Thank you, Shubhadeep. Right. So, the outermost pole should be before unit circle. Right. That means if the outermost is before unit circle, all are before the unit circle. Outermost means the largest one. The largest is inside unit circle. That means every pole is inside the unit circle. So the conclusion, very important conclusion that you are going to remember here is all poles inside unit circle. All the poles inside the unit circle. So now guys, let's have a look into the question here. The input-output relationship of causal stable LTI system is given to you. So can I find out the poles of this system by the given difference equation? Why not, sir? Why not? What is given to me? Y of n is alpha yn minus 1. First difference equation is given. Uske baad hai plus beta xn. Plus beta xn. Converting all of them to the z transform. Y of z is equal to alpha. Time shift property. Yz z raised to the power minus 1 plus beta xz, and combining all the terms of yz Okay, and then further dividing by xz, and we all know the ratio of the output z transform to the input z transform for a system is known as the transfer function for the system. The ratio of output z transform to the input z transform is known as the transfer function of the system. So here I define the transfer function. Suppose hz is yz upon xz, so that is going to be beta on the right hand side divided by 1 minus alpha z inverse. So where is the pole of the system now? Where is the pole of the system? So this is known to have only one pole, and that pole is going to come up as, alpha. Z inverse is 1 by alpha, so Z will be alpha. So there is only a single pole, that is Z equal to alpha. There is only a single pole, that is Z equal to alpha. And if there is a single pole, that is Z equal to alpha. Right? Okay. There is a single pole. Now, if the impulse response of the system satisfies summation Hn. Acha guys, one more thing. Summation Hn. I told you something about summation Hn. Recall, summation of Hn. Like summation of Xn. Summation Xn, Hn, नाम में क्या रखा है? Summation of Hn from 0 to infinity is known as H1. Is it the case? Oh, sorry. Is known as H0. Is known as the value of summation 0 to infinity. Yeah, that is H1. The summation property, guys, we listen to the summation property, na? Okay, it is equal to the H1. Recall the summation property in that S equal to 2 alpha question. S is equal to 2 alpha question. So, यहाँ से H1 निकालना पड़ेगा. Okay, let's forget pole is not required. Okay, H1 निकालना पड़ेगा. So, what should be the value of H1? Right. What should be the value of H1? It is summation of Hn. And summation of Hn is given to be 2. That means H of 1. What will be H of 1? Beta upon 1 minus alpha. Z inverse will be 1, and that is equal to 2. Beta upon 1 minus alpha is 2. How the relations are given? Alpha ko express karna hai. Right. So beta is equal to 2 minus 2 alpha, and alpha is equal to 2 minus beta whole divided by 2. Yeah, 1 minus beta by 2. Alpha is the 1 minus beta by 2. Option number A. Right. Alpha is equal to 1 minus beta by 2. That is the option number A. Okay. So this is what, see, since the question introduced the word causal and stable LTI system, so I made you revise the important points that you should know in general. Although this question isn't using these points, but this is what you should know actually in general. So the question number 9 is now here ready on your screen. The transfer function of a discrete time. LTI system is given to you. 2 minus 3 by 4 z inverse upon 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2. The system is stable and causal, or not stable, not causal, for the different ROCs. Now, because the ROCs are involved, so calculation of pole is important. The calculation of pole is important. So let me calculate the poles here. Right, that will be by the equation 1 minus 3 by 4 z inverse plus 1 by 8 z power minus 2 is equal to 0. Now, can we factorize this? See guys, 3 by 4, 1 by 4 plus 1 by 2. And multiply 1 by 4, 1 by 2, you get 1 by 8. So this is factorized as 1 minus 1 by 4 z inverse, 1 minus 1 by 2 z inverse equal to 0. Solving them, you are going to get the pole as z equal to 1 by 4 and 1 by 2. Z inverse will be 4 and 2, so Z is 1 by 4 and 1 by 2, right? Summation wala property, Shubhankar, I have explained you probably with the question number 3 or 4th of today. So you can rewind it maybe if you were not available earlier. Okay, summation wala property, question number 3rd or 4th. There I introduced the summation property. You can just go and check there. So we have the two poles at Z is equal to 1 by 4 and 1 by 2, right? We have the two poles at Z is equal to 1 by 4 and 1 by 2. Right, these are the only two poles. So what are the possible ROCs? Forget the S1, S2, S3. Let me give you everything. Let me give you every possibility. Right, what are the possible ROCs when there are two poles given? See, ROC can be right-sided, left-sided, or a ring. It cannot be entire Z plane here because there are the poles, na? So usually we have seen 4 types of ROC: entire Z plane, right-sided, left-sided or a ring between two circles, right? So right-sided ROC की बात करेंगे. So the right-sided is exterior of a circle, the outermost pole. So which is the outermost? Which is the largest one? 0.25. Mod Z greater than 2, right? This is number 1. Number 2 ROC. Mod Z less than 1 by 4, interior of a circle, and whenever the ROC is interior, you have to take it inside the innermost pole, inside 1 by 4, inside the innermost pole, right? And number 3, right? It is a ring, the ring between 1 by 4, say 1 by 2, 1 by 4 less than mod Z less than 1 by 2. Now just think in this case, right? This is a right-sided ROC. Right-sided ROC means the system is causal. Does it include unit circle also? Does it include unit circle? Mod Z greater than half. So it can be 1 also. Unit circle means mod Z equal to 1, right? So it is stable also, right? This is mod Z less than 1 by 4. Is it an exterior ROC? I told you, na? I told you for a causal system, ROC is exterior of a circle always. Exterior of a circle. Right, so whether this is exterior, no, this is interior, so it is non-causal. It is non-causal, it is actually anti-causal. Plus, is it stable? Mod Z less than 1 by 4, less than 1 by 4, so it cannot be 1 also. It cannot be 1, so this is unstable. Right. ROC between 1 by 4, say 1 by 2. Again, the ROC is not exterior, it's a ring, so it is non-causal. Plus 1 by 4 to 1 by 2. So it cannot include unit circle again. It cannot include unit circle again. This is the complete story. Now any type of options they can make. Any type of option they can make. The system is stable and causal for first ROC. True. This is what is true. The system is stable but not causal. For the second ROC, it is neither stable nor causal. So this one is wrong. The system is neither stable nor causal. For the third ROC, ये correct है. For third ROC also, it is neither stable nor causal. So this is correct. So according to the options, both S1 and S3 are true. Option number C. Both the S1 and S3 are true. Both the S1 and S3 are true. Both the S1 and S3 are equal to true. Let's move ahead to the next question. Question number 10, now ready for you. Consider the digital filter structure shown below. See guys, this is nothing about design of digital filter because very recently since GATE 21, digital filter design has been removed from the GATE. Okay, this is nothing related to digital filter design, but it's a very logical question on stability and causality. What is the value of K for the system to be stable and causal, and what is the combined condition for the stable and causal? For a system to be both stable and causal, the combined condition that we have learned is all poles inside unit circle. All the poles inside the unit circle. All the poles inside the unit circle. All the poles inside the unit circle. Before we move ahead, okay, again, otherwise if I forget, before that let me tell you that like every day you get the PDF of this session, and the PDF is going to be password protected, and the password is poles. The password is poles, P-O-L-E-S. The password for this PDF is going to be poles. Simple password, randomly framed, P-O-L-E-S, and the PDF will be in the Telegram group, in my Telegram group, right? So you can avail the PDF here, right? Chalo. Okay. So yeah, let's move ahead. Let's start the question number 10 discussion. First of all poles inside the unit circle. So where are the poles? To calculate the poles, I need the transfer function of the system. I need the transfer function. So देखो ध्यान देना. This is yn. Let's say the z transform of yn is yz. Z transform of xn is xz. Right. And let's say this is some intermediate signal. Let me call it as wz. So this is wz into z inverse. It is the output. Output of any block is input into gain. In the block diagram theory, it is input into gain. Ab dekho, this is multiplied further by minus k by 3 and fed to the summer. Right, fed to the summer. So what should be the wz? Oh, what should be this wz? this WZ can be written, it is the output of a summing point where first signal coming to the summing point is XZ, and from the below what is coming is minus K by 3 gain multiplied by WZ Z inverse. Let us take all the WZ terms on the one side, then it becomes 1 and plus K by 3 Z inverse should be equal to the XZ, should be equal to the XZ. Okay, so what should be the WZ, guys? What should be the WZ? Sir, it is X of Z is divided by 1 plus K by 3 Z inverse. 1 plus K by 3 Z inverse, right? Now, what should be the equation for YZ? Next calculation. What should be the equation for YZ? Now, as you're able to see, YZ is again the output of summing point where one of the input is WZ, the intermediate signal WZ, and another one is coming from the bottom line. This is going to be multiplied by the branch gain minus K by 4. So, plus minus K by 4 with WZ inverse, minus K by 4 WZ Z inverse. Okay. So, come on, let's solve it up. Okay, so we have WZ to be taken common. Y of Z is equal to WZ is multiplied by 1 minus K by 4 Z inverse. 1 minus K by 4 Z inverse, where what should be the value of WZ? Substitute the WZ from the previous equation, that is X of Z upon 1 plus K by 3 Z inverse is multiplied by 1 minus K by 4 Z inverse. All okay, guys? So now, eventually, what is the transfer function again? So the transfer function is once again the ratio of output Z transform to the input Z transform, which is 1 minus K by 4 Z inverse is divided by 1 plus K by 3 Z inverse, right? What is the pole? Now, the question is about stability and causality, and for system to be both stable and causal, all the poles must be inside the unit circle. So, where are the poles? So, I am able to see that there is only going to be one pole. There is only going to be one pole. After solving 1 plus K by 3 Z inverse to 0, you get Z inverse equal to K by 3 or Z inverse minus K by 3. So, Z will be equal to minus 3 by K, right? The Z inverse will be, sorry. Minus K by 3 only. The pole itself will be minus K by 3. So, Z equal to the minus K by 3. Correct? That is the pole. Now we need all poles inside unit circle. All poles inside unit circle means the unit circle is mod Z equal to 1. We want the poles inside unit circle. That means all the poles must have the magnitude which is lesser than 1. All the poles which have magnitude lesser than 1. Hi Arun. All the poles should have the magnitude lesser than 1. So we need modulus of Z to be lesser than 1. Modulus of minus K by 3 less than 1. Modulus of minus 1 is 1. So you are eventually left with mod K less than mod 3, and mod 3 is 3. Mod K less than 3 should be the answer for the question. Mod K less than 3 should be the answer for the question. Mod K less than 3 should be the answer for the question. So see, the question just uses digital filter. The digital filter design has been removed from GATE. Okay. But the analysis can be done. And there's nothing regarding filter. It's a stability and causality question. Mod K less than 3 is the final correct answer. Mod K less than 3 is the final correct answer. This was the question number 10 for today. And now, guys, coming to a very interesting and very good question. A very, very interesting and a very good question here. Question number 11 out of the 11 most expected question. This from the Z transform is a very good question. Take your peaceful time to solve the question. It's a very good question of GATE 2 mark, probably one of the best questions. Of Z transform. Take your peaceful time to solve these questions. This is like a homework for you, but don't worry, sir. Why you are leaving the very, very good question as homework? I will give you the answer also. I will give you the solution also. But I want you to try collecting all the points. Causality, stability, furthermore H1. देखो क्या क्या use करना है. Causality and stability point has to be used with a rotational typo error, with a rational transfer function. What is a rotational transfer function? मैंने तो कभी नहीं सुना, right? It's a rational transfer function whose corresponding impulse response begins at n equal to 0. That is why it is said to be causal. Further, h of 1 is equal to 5 by 4. Where do you use h of 1? Where do you use h of 1? Impulse response begin at n equal to 0. Matlab h of 0 will be non-zero. H of 0 non-zero. H of 0 non-zero means I told you something. Degree of numerator equal to the degree of denominator. Just revise the whole lecture. Right. H of 1 means summation point you can use. H of 1 is known as the summation of Hn. Summation point भी आ गया यहाँ पे. Summation of Hn is 5 by 4. H of the impulse response begins at 0. मतलब H of 0 will also be a valid value, non-zero value, right? And whenever h of 0 is not equal to 0, degree of numerator should be degree of denominator. Collect all those points. The poles are given to you. Acha, if the degree of numerator equal to degree of denominator, okay, so how many poles are given? K equal to 1, 2, 3, 4. You have to write down these poles. So there are 4 poles. Right, and because the numerator denominator degree is equal, so there has to be 4 zeros. If there are 4 poles, degree of denominator and numerator same, so from numerator also you will get the 4 roots. So there should be 4 zeros, and all the zeros are located at origin. Lots of hints I've given. Still after that it is going to be little, conceptual. So it's a very good question, guys. Very good question, which is going to be homework for you. But don't worry, sir. Why that very good question as homework? Hints have been given to you sufficient. Right. The answer, not only the answer. What I'm doing here today is solution to be available in Telegram. Solution in Telegram will be posted separately. The solution in my Telegram group will be posted separately, right? Correct. The solution in Telegram to be posted separately. Yes, definitely, Soumitra. Because H1 is summation Hn. Summation Hn finest means the signal is summable. Absolutely summable. Okay. Okay, it is summable. We don't say absolutely summable. We call it as summable, Soumitra. So solution of this question, this detailed solution will be there in the Telegram. Okay, password I have already given to you. Right, to join the Telegram, I'll give the PDF also of the entire session and also the solution of this particular question in Telegram. Okay, password of the PDF is already disclosed earlier. So a quick reminder, guys, that first of all, what we are doing tomorrow, same time, 9 p.m. Now I am having the session of DTFT and its properties. So as I told you, DTFT and Z transform has a very good connection that I have shown you in the first class also. DTFT and Z transform connection. So DTFT and the properties of DTFT. Also tomorrow, ye bhi tomorrow hai after the DTFT. DTFT is there at 9 p.m. So tomorrow night, 11 p.m. Tomorrow night, 11 p.m., you have the session regarding to the notes, detailed notes, short notes, micro notes. What are more important, what more to focus, and how to make, when to make notes for the GATE examination. And guys, on this Sunday, and this time it's me only, the workshops that are very useful for students, the strategic work of the free mega workshop. So this Sunday, I'm coming live on the BYJU'S exam prep app. 7 golden rules to secure single digit rank in GATE. Live 17 July, Sunday at 12:30 p.m. This coming Sunday at 12:30 p.m. With this, I, Rakesh Talreja, will sign off for the session. Okay, guys. You can search Conquer GATE and ESC by Rakesh Talreja Charan. Right? Chalo. No issues. I have shared the link also. So you can join the Telegram using the given link. Okay, guys. Bye-bye. Thank you. Stay safe. Take care. And let's connect tomorrow at 9 p.m. Also at 11 p.m. I have 2 sessions tomorrow. Bye-bye. Thank you. Stay safe and take care of yourself.